a bit. Is my screen visible, Raksha?
Yes, ma'am.
Okay. So we'll just go with this topic, okay? Basic things needed for understanding the isomerism. Do you have any idea about isomerism?
Yes, ma'am.
Okay, what do you know about isomerism?
Ma'am, the different ways in which a bond can be changed. The molecular formula will be same, but the structure will be different.
Okay, so the compounds will be having same molecular formula, but they will be having different kind of arrangement of atoms, right? So related to that, we will see some basic things. The first basic thing that you need to know is degree of carbon. Okay, what is degree of carbon? You have any idea?
I think three.
No, not like that. See, degree in the sense what? We just assign 1 degree, 2 degree, 3 degree for carbon atoms, alcoholic groups, and for other kind of functional groups. So what is this degree? Basically is, if you take for carbon atom, the degree of carbon atom is defined as the number of carbon atoms that are directly connected with it. For suppose if I take this molecule, what is this molecule? This is propane, right? For suppose if I focus on this second carbon atom, can you tell me how many carbon atoms are directly connected with this second carbon atom?
Two, ma'am.
2. That means this carbon atom is having 2 degree.
2 degree.
So how do we define the degree of a specific carbon atom? It's the number of carbon atoms that are directly bonded with that carbon atom. Now if you take the extreme carbon atoms, can you tell me their degree? First carbon and third carbon?
Degree 1.
Degree 1, because they are connected with only one carbon atom directly. Okay, are you clear with this degree of carbon?
Yes, ma'am.
Depending on the number of carbon atoms connected, we just allocate 1 degree, 2 degree, 3 degree, 4 degree. What do we call this 1 degree carbon? This is called primary carbon.
Primary.
And what about 2 degree?
Secondary.
Secondary carbon. 3 degree?
Tertiary.
Tertiary. If there is any difficulty in understanding the handwriting, let me know, beta.
Yes, ma'am.
What about 4 degree?
Quaternary.
Quaternary. Quaternary carbon atom. Can we expect any 5 degree carbon atom?
No, ma'am.
Why is it so?
And because carbon, it is able to form only 4 bonds,
Ve-
not more than that.
Very good. The carbon capacity is 4. Carbon has a covalency of maximum only 4. It can form only 4 bonds. So maximum linkage is 4, not beyond that. Okay.
Yes, ma'am.
Now, how do you find the degree of hydrogen atoms? Let us understand with the same example. If I take the secondary carbon atom here, can you tell me the number of hydrogens that are connected with this 2 degree carbon?
2.
2 hydrogens. That means we have 2 hydrogens whose degree is 2. If I ask you secondary degree hydrogen atoms, it is 2. Because the number of hydrogens that are connected to 2 degree carbon is 2. The degree of carbon is nothing but the degree of hydrogen.
Yes, ma'am.
Okay, so if you take the second carbon atom here, its degree is 2. That means the 2 hydrogens connected to this second carbon atom, both of them are 2 degree hydrogens. So I can say degree of hydrogen atom is nothing but what? Degree of carbon atom. Is this point clear?
Yes, ma'am. Ma'am, in
Mm.
the first and third carbon,
Mm.
it has 3 hydrogen atoms. Then degree of hydrogen will not be equal to the degree of carbon.
If you take the first carbon, what is its degree? It is 1 degree carbon, right?
Yes, ma'am.
So what about these 3 hydrogens connected to the first carbon? These 3 hydrogens are of 1 degree hydrogens.
Oh, each one is 1 degree.
Each one is 1 degree.
Yes, ma'am.
Now if you take the third carbon atom, this is also 1 degree carbon atom. So what about the degree of these 3 hydrogens now? They are
One.
also 1 degree hydrogens. So if I take this specific example, can you tell me the number of 1 degree hydrogens now? It is a total of 6.
Yes.
Got the clarity now?
Yes, ma'am.
Okay, so we have an example here. Let us do this one. Okay, find 1 degree hydrogen atoms and 4 degree hydrogen atoms. This is what we have to do in this question. Will you make a try?
Yes, ma'am.
1 degree hydrogens means first what you have to do, first to find 1 degree carbon atoms. 4 degree hydrogens means first to find 4 degree carbon atoms. So this is 1 degree, this carbon is 2 degree. What about third one? This is 3 degree and this is 4 degree. 1 degree, 1 degree, 1 degree, 1 degree. Are you clear with degree of carbon in this example?
Yes, ma'am. And for 1 degree, it is 3 plus 3.
If you take 1 degree hydrogen atoms, check for 1 degree carbon. So here we have 1 degree carbon and here we have 1 degree. One more 1 degree, one more 1 degree, one more 1 degree. So total how many do we have? 1, 2, 3, 4, 5, isn't it?
Yes, ma'am.
Now if you take every 1 degree carbon, it is connected with only one other carbon. Remaining 3 bonds are left. Those 3 bonds are made with hydrogens.
Yes, ma'am.
Isn't it? So every 1 degree carbon has 3 hydrogens with it. So here total we have 5 degree carbons, 1 degree carbons 5. Each will be having 3. So total how many hydrogens? 15 hydrogens.
Yes, ma'am.
Any doubt so far?
No, ma'am.
No. Okay. Now tell me what is the count of 4 degree hydrogens?
0.
0. Because if you take 4 degree hydrogens, it means the carbon degree also must be 4. Already 4 bonds are done. No hydrogens are connected. So if I take the number of 4 degree hydrogens, it is 0.
Yes, ma'am.
So are you clear with degree of carbon and degree of hydrogen? Any doubt in this?
No, ma'am.
Okay. Now we'll go for degree of alcohols. What is alcohol? It is basically considered as a functional group, right?
Yes, ma'am.
There are so many functions. I think you are aware of this because already you have completed some part in your college, right? Aldehydes, ketones, esters, sulfonic acids. There are different kinds of functional groups. When we start the regular classes, I'll explain you in detail. Now when we talk of alcohol, it is also a functional group. It decides the function of the molecule. That is why it is called as functional group. It's a group of atoms which will decide the function of that compound. Okay.
Yes,
What is the formula of alcohol functional group? You have any idea?
ma'am. Alcohol, it is OH.
OH. That means the other side it is connected with carbon. Generally we don't have one carbon, we have a bigger chain of hydrocarbons. So we just represent with alkyl group or OH.
Yes, ma'am.
Clear? And on the oxygen atom we have two lone pair of electrons. This is your alcohol symbolic representation. Now how do we decide the degree of alcohol? We have to check the degree of carbon atom at which that alcohol group is present. For suppose, take this example. You take the first example. We have an alcohol group here. This is connected to which carbon atom? This is connected to this carbon atom, right?
Yes, ma'am.
Now this carbon is connected to how many carbons? 1,
2.
2. So the degree of this carbon atom is 2. This is 2 degree carbon. So alcohol is also what? 2 degree alcohol. To decide the degree of alcohol, we have to check the degree of carbon to which that alcohol group is attached.
Yes, ma'am.
Clear with this? Now can you tell me the degree of alcohol in the second example? This is your alcohol. It is attached to this carbon.
Yes, ma'am. 1 degree.
1 degree. So if you take this carbon, it is directly connected with only one other carbon. So this is 1 degree carbon. So this is 1 degree alcohol.
Alcohol.
So this is how we decide the degree of alcohols. Now I have a question for you. We have an example here. What is this part called? Any idea, Raksha? This is called benzene, an aromatic compound, right?
Yes, ma'am.
Which shows resonance phenomena, which has delocalized electrons, which have alternate single and double bonds. You know pretty information about it. This is benzene. Now on the benzene, we have some OH group which is alcohol. Now can you tell me the degree of this? Alcohol.
2 degree.
Alcohol is attached to this carbon. This is further attached to two more.
Two.
So this is 2 degree carbon. So we take it as 2 degree alcohol, right? Generally. So if you say it as 2 degree alcohol, then this is a wrong answer. Why is it so? Because this given compound doesn't belong to alcohol functional group. This completely belongs to phenol family. Because I told you what is alcohol family, ROH. R must be an alkyl group. But what is the attached part here? What is the, you know,
Benzene.
benzene? So benzene is not an alkyl group, right?
Yes.
Benzene is not R group. ROH is our alcohol. But here the remaining part other than OH, it's not an R group, it's a benzene. So first of all, this is not at all an alcoholic compound. So how do you decide the degree for it? Getting my point, Raksha?
Yes, ma'am.
So these kind of examples you have to be careful, because there is a probability of asking these kind of questions in exam. Okay.
Yes.
Okay, so this is not, you can't decide the degree for it because it is not at all an alcohol. It belongs to phenol family. Okay.
Yes, ma'am.
And now, for suppose you have a compound like this, there is no alternate single double bonds. This is just what? Cyclohexane. Okay, you are removing one hydrogen, then it becomes cyclohexyl. Obviously it becomes R part, and OH is present. Now this is belonging to alcohol family. Now you can decide the degree of this alcohol. What is the degree of this alcohol now?
2 degree.
2 degree. This is 2 degree because the carbon at which this OH is present, that is 2 degree carbon. Clear?
Yes, ma'am.
Now we'll see degree of amines. What is amine basically?
And
Amine is NH2. NH2, and it is attached to carbon. Generally we take alkyl group. Okay. On nitrogen, how many lone pairs are present, Raksha?
two.
Nitrogen has 5 valence electrons.
One lone pair, just two electrons.
One lone pair in the sense 2 electrons. Okay, so RNH2 is the symbolic representation for amine functional group. Now how do we decide the degree of amines? We have to see the number of carbon atoms directly connected with the nitrogen atom. How many carbons are directly connected with nitrogen? That will decide the degree of amine. For suppose, see the below example. First example, now this is your amine. So to the nitrogen, directly how many carbon atoms are connected? Only one. So this is 1 degree amine. If you take second example, this is our amine. Directly how many carbons are connected to nitrogen? Only one again. So this is also 1 degree amine. Now will you make a guess for third one? What kind of amine is that?
Secondary.
Secondary. Because secondary, how many nitrogens are directly connected with that? How many carbons are directly connected to
Oh,
nitrogen?
one
Only
degree.
one. So this is 1 degree. For alcohol, we take the degree of carbon. But here we see how many carbons are directly attached with nitrogen.
Yes, ma'am.
Okay. And moreover, there is an exception here. Though amine is RNH2, here this is benzene group, but yet it is considered for amine. Okay.
Yes, ma'am.
If you see the past example, for alcohol we didn't consider the benzene part. It was phenol family, but here it is considered for amine group. Okay.
Yes, ma'am.
And what is the common name of this? This is aniline. On the benzene ring, if you have one NH2 group, it is called aniline. Okay. Aniline is what kind of amine? It is 1 degree amine, primary amine. Okay.
Yes, ma'am.
Now we will do some examples. Tell me the degree of nitrogen atoms here. Total we have 3 nitrogens. Tell me the degree of those. First one, second one, third one. What is the degree of first nitrogen?
First nitrogen is
1 degree, because only one carbon is directly connected. So this is 1 degree amine. What about second nitrogen?
1 degree.
1 degree, because here also only one carbon is directly connected. Third one,
2.
2 degree, because two carbon atoms are directly connected to the third nitrogen atom. Clear?
Yes, ma'am.
No. Go for this example. This is example 2 and this is example 3. Tell me the degree of amine in second example.
Second one, it is 2.
So one carbon, another carbon, two carbons are attached. So this is 2 degree amine. Now in example 3,
3.
what is this Me? Me is a shortcut for methyl group. Okay. If they write Et, it is a shortcut for ethyl group. Ethyl is C2H5 group. In shortcut, we'll write it as Et. Methyl is CH3. In shortcut, we'll write it as Me. Okay.
Yes,
In
ma'am.
every methyl, one carbon. Here also one carbon and one more carbon from benzene ring. So total 3 carbons are directly connected. So nitrogen atom here is what? 3 degree amine. Now, are you clear with the degrees? Most of the questions will be related to degree of alcohol, degree of amines, and degree of hydrogens and degree of carbon atoms.
Yes.
Any doubt in this?
No, ma'am.
No. Now we'll see the next topic, that is degree of unsaturation. It has different names. It is also called index of hydrogen deficiency, unsaturation index, and double bond equivalent. In most of the books, we find double bond equivalent, but there are other names as well. Unsaturation index, degree of unsaturation, hydrogen deficiency index, all mean the same. Okay. It has 3 definitions. You have to know the 3 definitions, because in exam we don't know which definition will be helpful to solve the problems, right? We'll see the first one. This is with respect to pi bond. Number of hydrogen molecules required to convert the given molecule, this is very important, into open chain saturated compound. What is the meaning of open chain, Raksha?
Open chain where the oxygen is like in double bond and not connected to carbon.
Open chain in the sense structure will be open. See, every molecule is having some structure, right?
Yes, ma'am.
It can be linear structure, it can be branched structure, it can be closed structure. Open chain in the sense structure is open, it doesn't have any rings in it, no closed rings, no cycles in it, it's completely open.
Yes, ma'am.
If you take benzene, it's a closed compound. If you take propane, ethane, butane, they are all open chain compounds, no rings in the sense open chain. Okay. And what do you mean by saturated?
Single bond.
Saturated means, yes, carbon to carbon we will have single bonding. Okay. Carbon to carbon, we don't bother about other atoms bonding, we just see between carbon to carbon. If it is a single bond, we take it as saturated compound. Okay.
Yes, ma'am.
So we are given a molecule, we have to convert that molecule into what? Open chain compound plus saturated compound. So to do this task, to do this job, how many hydrogen molecules are required? That is nothing but your double bond equivalent.
Yes, ma'am.
Okay, we'll do an example so that you'll understand. For suppose, I'll just take CH2 double bond CH2. Can you tell me the name of this molecule? What is
Ethene.
ethene? Because it is having 2 carbons and it is having double bond. Now I just want to convert this ethene into saturated compound. Ethene is having double bond. So what is this basically? This is an unsaturated compound, right?
Yes, ma'am.
Now I just want to convert this into saturated form. How can I do this? How is
By
this process?
adding H2 in the presence of some catalyst like nickel or palladium.
Yeah, we just need to do some addition reaction. You can add any kind of atoms, but generally we consider hydrogen atoms. Okay. You
Yes,
can do
ma'am.
hydration, you can do chlorination, but generally we consider what? We consider hydrogenation. Now, if I take the first carbon and second carbon, their 3 bonds are done and fourth bond is an extra bond. I'll just break this extra bond. extra bond has to be broken. Now if I break that extra bond, Raksha, what happens? The carbon atom get their fourth valence electron, right?
Yes, ma'am.
Now, after breaking the bond, can you tell me what is the number of bonds for each carbon?
4.
After breaking the bond.
After breaking, it will be like 4. 3 hydrogen and 1 with 1.
After breaking, this is how it is, right?
Yes, ma'am.
Now
And
how now how many bonds for each carbon?
3 for each carbon.
3 for each carbon. So fourth bond has to be formed, right? So
Yes,
what
ma'am.
will I do is, for two
Hydrogen.
carbons here, we'll just add one hydrogen for first carbon, another hydrogen for second carbon. So overall we are adding two hydrogens. That means we are adding one H2 molecule, right?
Yes.
Now it is converted into saturated compound, that is ethene. This is
Yes.
saturated. Now to do this process, can you tell me how many molecules of hydrogen are required?
1.
One molecule. So I can say degree of unsaturation for this reaction is 1, because one hydrogen molecule is added.
Yes, ma'am.
Now why one hydrogen molecule is added? Because there is one double bond. If there is one double bond, one hydrogen molecule is required. For suppose if there are two double bonds,
2 double bonds, 2 moles of hydrogen.
2 moles of hydrogen. So we can say what we have to do is we just have to observe the given data, given molecule. If the number of pi bonds is 1, degree of unsaturation 1. Number of pi bonds 2, degree of unsaturation 2. Pi bonds 3, degree of unsaturation 3. Number of pi bonds 4, degree of unsaturation is 4. Why is it so? Because the number of H2 molecules required will be equal to number of extra bonds present, that is number of pi bonds present. Is this point clear?
Yes, ma'am.
Any doubt in this?
No, ma'am.
So first definition was according to the presence of pi bonds. Now second definition is according to the presence of rings. What we need to do is, whenever a closed ring, in the sense what, it's a closed compound, right?
Yes, ma'am.
As I told you, in degree of unsaturation, always we have to convert the given molecule into open chain compound. Structure must be open. It should not have any rings. We have to convert into open chain saturated compound.
Yes,
So
ma'am.
to do that, for suppose if the given molecule is cyclic compound, given molecule is a cyclic compound. Now then what we have to do, we just have to break the bonds. Bonds have to be cleaved. How many bonds will you break to make it open? That is your DBE. For suppose, I'll just take an example. I'm just taking the square one. Can you tell me what is the name of this? This is cyclobutane, because we have 4 corners. That means 4 carbons, all single bonds, a butane, cyclic structure, cyclo. Clear?
Yes, ma'am.
Now, butane, in the sense it is already saturated, all are single bonds. Now what we have to do, we just have to make it open now. Already saturated, we just have to convert into open form. So how can we do this? I'll just take one bond here. I'll just break that bond. If I break the bond, what happens, Raksha? This is how it will look, right?
Yes, ma'am.
Now also it is butane. Now also we have 4 carbon atoms, but now it is not cyclic form. It is open structured butane, right?
Yes, ma'am.
So in this case, how many bonds am I breaking?
1.
1. So one bond is broken to make it what? Open chain saturated compound. So double bond equivalent in this case is 1.
1.
Why is it so? Because you are breaking one bond. How many bonds are broken to convert a given molecule into open chain saturated compound? That is your DBE.
Yes, ma'am.
So can I say now double bond equivalent is equals to number of rings in the compound? If there is one ring, you have to break one bond. If there are two rings, you have to break two bonds.
Yes, ma'am.
Okay, then it will become what? Open compound. Now, number of rings is 1. Now, can you tell me the double bond equivalent
One,
in all the 1, 2, 3, 4? Clear?
four. Yes, ma'am.
Now, so we have some questions. Let us do this. After that, I'll wind up the class. Okay? We'll have
Yes.
some practice. So see this, we have to find the degree of unsaturation. Remember the first two definitions that I told you. Number of pi bonds and number of rings. This is also double bond equivalent, and number of rings in the sense you have to break the number of bonds. One ring, one bond to be broken, so 1 dBe. One pi bond, you have to add 1 H2, so 1 dBe. So you just take the summation of pi bonds plus number of rings. That will be equal to what? Double bond equivalent. Fine.
Yes, ma'am.
Now, can you tell me the double bond equivalent value here?
1.
Oh, what is the formula for double bond equivalent? How do we find?
And we have to break the pi bonds and make them saturated, and
Hmm.
we have to make this open, sorry, closed type into a open type.
Okay, fine. So read this first point. Number of hydrogen molecules required is number of pi bonds present. And
Yes,
number of hydrogens required is nothing but dBe, right?
yes, ma'am.
Now see this table. Pi bonds 1, degree of unsaturation 1. So how many pi bonds are present? That much is the dBe. How many rings are present? That much is the dBe. Are you clear with these two tables?
Yes, ma'am.
Now tell
Ma'am,
me the answer for this question.
here carbon is connected with oxygen, no, ma'am, in double bond. So only with carbon and carbon we can add hydrogen.
We have to take the whole molecule and we have to convert the whole molecule into saturated form.
Okay.
Earlier I just took only hydrocarbon example, but it's not like that only between carbon to carbon. Okay,
Yes, ma'am.
like
Then
if you see one pi bond, two pi bonds, three
3 pi.
pi bonds, and this is one ring.
So 4 totally.
Four totally. So if you take dBe here, it is number of pi bonds plus number of rings. Pi bonds are 3 and rings is 1. So what is the total degree of unsaturation now? 4. Clear?
Yeah.
Any doubt, Raksha? Any confusion?
No, ma'am.
You have to ask me, you have to feel free. If you don't ask me, I don't know what is running your mind. Unless and until you ask me, I cannot help you.
Okay, ma'am.
Okay. Now what about the answer for this question?
It has no pi bonds, so we have to find only about the rings.
You don't find any pi bonds in this structure?
Mm,
First of all, tell me how many rings are present in this structure?
3 rings.
Only 3? See this part? See this part?
Oh, then
Now here also see this part?
yes, ma'am.
So this is 1 ring, 2 ring, 3 rings, 4 rings and 5 rings. We have 5 rings in the given structure. And do you find any pi bonds?
6 inside the benzene, so 6.
Yeah, inside the benzene we have pi bonds. So 1, 2, 3, 4, 5, 6. So total we have 6 pi bonds. Now what is the double bond equivalent?
11.
5 plus 6, 11. So this is the right answer. Now go through this question.
7.
How many rings are present?
3 rings.
1, 2, 3. So rings are 3. And how many pi bonds?
2.
Only 2.
Sorry, 4, 4.
4. So 1, 2, 3 and 4. So we have 4 pi bonds. What is the total dBe value now?
7 rings. 7 U.
7, right? 3 plus 4, 7. Now go through this example. This is the last example. After that I'll wind up the class. How many rings, tell me?
2 rings
1, 2. So 2 rings. Mm.
and 2 pi bonds.
So 1 and 2. So 2 rings and 2 pi bonds. So what is the total degree of unsaturation? It is 4 now. Okay,
Yes, ma'am.
clear? So
Yes,
if
ma'am.
you see all these examples, the question is in the form of structure. If you take every example that I took here, all are given in terms of structures. We don't know their formulae. But if you see the next examples, like this, they may give find the degree of unsaturation for C4H8, C5H10, Cl2. When formulas are given, we will use the third definition. Okay.
Yes, ma'am.
First definition was according to pi bond. Second definition was according to ring. These two are helpful when structure is given.
Yes.
Third definition, this is in terms of formula. That is helpful when the question is in terms of molecular formula. Okay, so that I'll tell you in later classes. Okay.
Yes, ma'am.
Any doubt?
No, ma'am.
No. Okay. So what did we discuss today? Can you summarize?
Ma'am, we started with basics of GOC,
Mm.
and then we talked about this number of
First, we discussed about a degree concept. We discussed it for carbon atom. We discussed it for hydrogen atom, and later we discussed it for alcohol group, and then we discussed it for amine group. Okay.
yes, ma'am.
And later we discussed about degree of unsaturation. Here we discussed two definitions. Okay,
Yes,
Raksha.
yes, ma'am.
Okay, then fine. So if you are comfortable, inform to ma'am. Then we'll start the classes from tomorrow. Okay.
Yes, ma'am.
Hmm?
Yes, ma'am.